let's look at how to find counterexamples to show the statements are false. So the first example, for any integer, so I'm going to use a to represent an integer. So any a in the integer set, so that means a is integer. So this symbol right here means in or belong to. Z means integer set. So first of all, this tells us what kind of numbers a can take. So for any integer a squared is greater than 0. Because the problem, the instruction tells us this, the statement is false already. So all we have to do is to find a counterexample to prove this is false. So it looks like if we pick some integers, 1, if we pick 1 squared is greater than 0 because 1 squared is 1. If we pick -1 squared is also equal to 1, which is also greater than 0. And similarly, you can pick 2 or even 1.5. It looks like this is true. But actually, don't forget, 0 is also integer. So when we look at this symbol right here, for any symbol, which means for this statement, a squared is greater than 0, works for any integer. Doesn't matter if it's a positive integer or negative integer or 0. Although we verified a squared is greater than 0 for most of the integers, we do have one that is a counterexample. So when we list the counterexample, you don't have to show these. You just show the one that doesn't satisfy this. So if we pick 0, so let a be 0, we get a squared is equal to 0. That is not greater than 0. So this is a what's the counterexample? The counterexample will be 0 for a. Now look at another example. In this first example, there's only one variable. If we have two variables, this statement for any xy, well, they could be actually this works for any integer or real number. For any real number, x plus y squared equals x squared plus y squared. Well, this actually is a common mistake in algebra class. A lot of students thought this was true. Actually, it's not true, and because we can find a counterexample or more counterexamples, here we just need to give one counterexample. If we just pretty much we just pick some numbers, and so it looks like if I pick, there are actually lots of counterexamples in this case. In the first example, there's only one counterexample, 0, but in the second case, there are lots of them. So if I pick 1 for x, and actually I can also pick 1 for y, and I plug them both onto the left-hand side. The left-hand side equals, be careful, the parentheses squared. So what's in the parentheses? 1 plus 1. And notice the order of the operations. We got to do the parentheses first. So we do 1 plus 1, that's 2. And we do 2 squared, that gives us 4. But if we plug both values for x and y into the right-hand side, that will give us 1 squared plus 1 squared. And in this case, we cannot do addition first. We got to do the square first, because the square goes, exponent goes before multiplication and addition. So we got to do 1 squared, that's 1, plus 1 squared, that's 1. And now we add them, we get 2. As you can see, the left-hand side is not equal to the right-hand side. So you can say, for these two values, 1 for x, 1 for y, and this equation does not hold. So that's a counterexample. Well, there are lots of others, and you just need to pick some.